All right, this is my second time running through this stuff today. I found some cool shit on my calculator I like. I'm gonna have to try it in a second. We are going over numbers today. We're really just gonna focus on the real numbers and fractions. Today, primarily, we'll do decimals and percentages on Monday. But let's talk about the real number line. If you're wondering why this crazy bastard is wearing gloves in the middle of fucking summer, look at my fingers. That's just from the part that is unprotected. I'm gonna have you guys for another 2 hours, and I got 4.5 hours in the afternoon. If I don't wear these like fingerless gloves, I'm gonna look like I just left my hands out with a kid with a pack of markers. I'm just gonna go home covered in ink. So I don't like that. So I wear gloves. All right, real number line. We make a line and we put 0 in the center and we put arrows on the end. And to the right we have numbers that increase in value and they're positive values. And as we go to the left, they become more negative. Now, we know those numbers aren't the only things numbers that we can make. We can make fractions and decimals and things in between. So we might be able to break these down into little subcategories. And if I did it halfway as a decimal is like 0.5. So halfway between 0 and 1 is like 0.5. Halfway between 1 and 2 would be 1.5 or like $1.50. It's always helpful if you can to turn this into thinking about money. And when I go the other way, it's really the same values as it would be going to the right, but now they're negative. If I go right one of these units, it's 0.5. If I go left one of these units, it's negative 0.5. And I've already got the -1 marked here. The next one would be 1.5, but it's negative 1.5. There's a reason why I'm telling you this. There's a question on my quiz that says, plot these values on a number line. And I'll give you a number line, and I'll give you some values to plot. So, like, maybe we need to go over it. I don't know how much you're gonna use it, but maybe it helps you think about how numbers work better, which should. There's a couple categories we have here. We have the whole numbers. Whole numbers are your countable numbers. Like if you were counting items. You start with 1 item, 2 items, 3 items, 4 items, 5 items, etc. We wouldn't say like we had 1.5 cars. That doesn't make sense. So like think whole numbers. There's no partial numbers. And those are the only whole numbers. We'll see in a little bit where you can do a fraction and have the equivalent of a whole number, but it's not the same. Integers, I don't know if they mentioned this, but I thought I better point it out. Integers are your whole numbers, 0, and effectively your, I'm gonna put this in quotes, negative whole numbers. On the line I have here, I have -4, -3, -2, -1, 0, 1, 2, 3, and 4. And they keep going. there is more numbers, obviously. The next number would be 5. I don't have it on my line. We normally put 3 dots to show that the numbers keep going. All right, then there are rational numbers and irrational numbers. Rational numbers has the word ratio in it. Ratio or fractions. Anything that can be written as a fraction. Integers fall in this category. 4 doesn't look like a fraction, but if I say 4 over 1, now it looks like a fraction, and it's the same thing. So 4 over 1, rational numbers are fractions. It also includes decimals that can be written as fractions. This decimal thing, I'm going to break it up into 2 categories. Decimals that end, like they don't go on forever, are always rational. You can always turn a number that ends, a decimal that ends, isn't gone forever, into a fraction. We will do that on Monday. We'll do it with ugly decimals too. Unending decimals sometimes. And the key here is if it can be written as a fraction. Often these decimals that can be written are as a fraction. I'm not going to say all of them, but I'm pretty sure most, if not all, repeating decimals. For example, 1 over 9 is the same thing as 1, 1, 1, 1, 1, 1, 1, 1, and it keeps going. It just keeps going. Things that repeat, whatever repeats, we write in a simplified form. We put the value that repeats with a repetition bar over it. I'm going to put a rational on the next page so I can put a little bit more on rational here. Like 3 over 11 is 0.27272727, And it keeps following this pattern. And so here we could write it as 0.27, and the bar goes over both the 2 and the 7. I try to stay aware and look around and make sure no one's writing when I turn the page. If I happen to turn the page and you're still writing, say something. If you say nothing, guess what? It's going away. If you say, hold on a second, Mr. Jones, I'll put it right back up. I see someone still writing, I think. Everyone good? Okay. I'm gonna write that number line again real quick, just real quick. Well, fuck it, let's do the irrational numbers first. Irrational numbers can't be written as a ratio or a rational number. Decimals that don't end and don't repeat are candidates for this. It doesn't always mean every single one that's doesn't do it works. For example, I just did 67 divided by 210. I have a decimal that's not repeating, but this is a fraction. I can write this as a fraction. So this is one of those unending decimals that isn't one of these ones. It's harder to like look at something and go, that's irrational if it's just written as a decimal. There are ones you guys have seen before with symbols and shit you've seen before that you'll be like, yeah, that's an irrational number. Examples of this are pi, which is approximately 3.14, but it's got more decimals that keep going on forever and ever and ever. Square root of 2 keeps going on forever and ever and ever and ever, but it to 3 decimal places is 1.414. And like any square root of a prime number is going to be in here, and some non-prime numbers, like negative square root of 3 is approximately negative 1.732. If I'm doing it in a calculator, everyone's calculator gets pi a different way. Mine is shift with the pi key down here. It's right above, you can't even barely see it. Right above the key that says EXP has a symbol of pi. I have to hit the shift key and then the EXP key, and I get this pi symbol. And if I hit equals, it tells me that. So I just rounded to 3.14. That's the common rounding for pi. I can do the same thing with square root of 2, wherever I can. I'm going to show you the calculator versions. Square root of 2, it gives me the whole value. We're going to be doing a lot of stuff with calculators. Some fraction stuff you just can't easily do with calculators. Not every calculator does it. Not every calculator has the fraction good fraction stuff. It turns out mine has more than I thought it did. I found it today. I was very pleased. So let's look at plotting on a real number line. I'm only going to go as far as I need. When it asks you to plot on a real number line, let's say, let's plot 1. On the number line. You find where that number is located and you put a dot. Bam. That's simple. If you want to plot a fraction, it's easier to write it as a decimal first. If I wanted to plot, let's go with 1/3. The fraction 1/3 is the same thing as 1 divided by 3. So the fraction bar, fraction kind of like means division or turns into division is a better way of saying it. If I do that on my calculator, I'm going to get 0.3333333333333, and it keeps going, so I'll write 0.3 bar. And then I look for 0.3333 on there. If I think of it like money, if I go to like 2 decimal places like money, I'm looking at 33 cents, which is above $0, but below $1. So you kind of want to go through and do like little markers in between where you can. And like mark the halfway point is usually a good thing to do. That's 0.5. And then 0.33 is closer to 0.5 than it is to 0. So I'll just say it's right there. It's closer to 0.5 than 0. That's 1/3. We can do the same thing with pi. Pi was approximately 3.14. I'm going to go to the 3. And 3.14 is more than $3, but it's less than $3.50. So I'm going to go like, and it's closer to $3. So maybe pi is right there. The middle point is 350. That's 3.5, and it's closer to 3 than 3.5, so we'll put a dot closer to 3. It's pretty straightforward. The ones it has you doing in the initial quiz don't have any irrational numbers or like weird repeating decimals. They're like halfway marks. It's like, where is 1/2? Where is 3.5? Where is -2? Where is -1.5? Let's take a look at -1.5. Now, unlike numbers that go to the right, that go up as they go to the right, the negative numbers go up or become more negative kind of thing as they go to the left. So negative 1.5 is halfway between -1 and -2. Negative 1.5 should be right there. Another way of looking at this is it is 1.5 units away from 0 in the negative direction. So like I had to go 1.5 that way. In fact, there's an operation or a set of math symbols that you've seen before that you may not think of like this. If I go 1.5 in the positive direction, I'm right there. And these are both 1.5 units away from 0. But I end up at 1.5 or negative 1.5. This is where we see the absolute value. Absolute value measures the distance from 0. And we use vertical bars to represent absolute value. So the distance of 1.5 from 0 is 1.5, and the distance of negative 1.5 from 0 is also 1.5. I don't know if that distance from 0 helps you any. Most people remember it as make the shit on the inside positive. After doing math. I didn't have any math to do here. We're going to do mathematical operations, like the series of them, talk about them more thoroughly on either Monday or Tuesday. The idea is here, if there's just a number in there, make it positive. If it's already positive, it's good to go. If it's negative, drop the negative. If only money worked this way. You guys ready for more? Is everyone ready? Did I pull it away too quick? Okay. All right, let's get to the good shit. Fractions. We're gonna be doing basically fractions all day. So let's start off with what the fuck is a fraction? Fractions. I think an easy way to talk about this is like showing a pepperoni pizza. Pizzas make great fraction calculators or demonstrations. So let's say that's a pepperoni pizza. I don't know why I put quotations or marks around it, but I did. That way you have something in your head. Like say this is a large pizza and I'm out with my wife and maybe a couple friends. And David eats 3 slices. We'll use a D for me, and I have 3 slices. And so I'll mark them. I'll say this slice is the slice I took that slice, and I took that slice. My wife, Angie, we'll use A. She took 2 slices. I will mark her here with an A. So how many slices do you eat, Cody? How many slices of a large pizza would you have?
Probably about 3.
3? Okay, let's put Cody in this 3. Three slices. Use green for the letters. This is too close to alphabetical. I'm gonna go with like a Mark. Mark said, you know what, I'm hungry. And he ate the last 4 slices. These, all of them add up to 12 slices. What fractions do is fractions show the relationship between a partial value and the whole. Partial amount and the whole amount. And we write them as partial over the total for the whole amount. I will quite I will quite frequently call this the top over the bottom. But I know one of the questions on that quiz is what are these things actually called mathematically? And every once in a while, I slip back into using a mathematical term. The top is called the numerator, and the bottom is called the denominator. That's the official math jargon, and it's going to ask you on the quiz, what is that called? That's a lot to remember. It's a lot to write. Do you know how often I fuck up the spelling of denominator, even though I've written it probably 1,000 times in my life, if not more? I write demonator more often than fucking not. I have to slow myself down to not write demon. Because it looks like demon if you switch the M in the end. That's just too much Dungeons and Dragons in my life. I don't know that other math teachers have that problem. All right, so let's take a look at what we have here for our people. David, Angie, Cody, and Mark. The total number of pieces or slices is the same for everybody. It's the number of slices that the pizza had before we touched it. That's our bottom. our top is what we ate. Any questions so far? Is everyone ready for the page turner? All right, so now let's take a look at like equivalent fractions or values. I'm gonna go back to our pizza thing real quick. I'm gonna draw the pizza the way it came. And then what if I didn't cut the pizza into as many slices? What if I just cut it into 4 slices? I had these 3 slices here, which was that portion of the pizza. Over here on the circle, the equivalent portion of the pizza is that. And Cody had these 3 slices. And over here, that's the equivalent of this part. On the left, these are both, if we look at the values, it's 3 out of 12, right? We each had 3 pieces out of 12 pieces. In fact, I kind of wanted to write down what I just said. I said 3 pieces out of 12 pieces. When you see this out of part with a number before it and a number after it, out of almost invariably means a fraction. Over here, we each had 1 out of 4 pieces, or 4 slices. So that as a fraction is 1 over 4. Since they represent the same amount of pizza, these values are equal. And that's what equal is the same thing as equivalent. So how can I go from 3 over 12 to 1 over 4 mathematically? Like I can draw a picture and see that they relate, but you got to draw a pretty good picture. I don't even know that I drew a good picture that actually makes it look like it's really the same. But we both know if it was cut evenly, it would. So the act of simplifying or reducing they usually say simplify, is writing the larger fraction as the smaller fraction. And what we do is we write the numbers on top and bottom. In terms of their factors. Which is a factor is like the two numbers that multiply to make a bigger number. This process of writing the numbers as smaller numbers multiplied together, the process is called factoring because you write them as factors. I kind of stuck using the word factor because it's a short word. And like, otherwise I gotta say this long thing of like the numbers that multiply together that make the bigger number. That's what factors is, or I usually use one word, factor. So factor is something to add to your vocabulary. So let's do that here. We had 3 over 12. Can I rewrite either one of those numbers as a multiplication of two smaller numbers? Anybody? Can I write 12 as a multiplication of two smaller numbers? Or what two numbers multiply together to make 12? 3 times 4 works. I can rewrite the number on bottom over here as 3 times 4. When we simplify, simplifying is crossing out values on top and bottom and replacing with a 1. You'll notice I use this dot here. We will be having some algebra shit later on. And I know a lot of people everyone should be familiar with seeing an X as a multiplication. But in algebra, we tend to use X for a variable or unknown quantity. So to do multiplying, we're going to use a dot. I don't think it's the best symbol. It's what people came up with long time ago. Why they didn't just make it a fucking asterisk where it's obviously not a decimal point, I don't know. When you see it in textbooks, sometimes it's dot. Some authors use like an asterisk for multiplication, which is handy. It's clearly not a decimal. No one puts a little star for a decimal point. Well, unless they're trying to be cute. Doesn't happen that often. So this dot right here, it's not in the same spot as decimal. Decimal points go at like the bottom of the numbers. When we have the dot like at the middle of the height, it's multiplication. If I do that canceling here, the crossing out values, I can cross out the 3 and the 3, and I can replace them both with 1s. It's important that you actually replace them with 1s. Because if you don't, if you just cross off the 1, it's easy right now to look at the top and say there's nothing left. what value do we associate with nothing? Zero, right? We associate zero with nothing. So if you don't put the 1, you might forget and say it's 0. I've seen calculus students that, like engineers, they've gone through the entire math sequence, which is like 8 fucking courses. And I've seen them do simplifying like this and put 0 on top. So that's a no-no. Put a 1 so you don't forget. And now I've got a 1 on top, and 1 times 4 is 1 over 4. And now I've got my 3/12 down over to 1 over 4, or 1/4. Any questions so far? Anyone need it up longer? Everyone good? Okay, so that was easy because someone came up with 3 times 4 right away. What if that's not the first value you think of? 3 doesn't get any simpler than 3 times 1. And there's not a lot of point in writing 3 times 1 because you can't cross off a 1. It's already a 1. But what if you thought, oh, you know what? I know it has 12 in it, like a carton of eggs. A carton of eggs is 2 rows of 6. You might have said 2 times 6. The point is you may not have come up with the right factors at first to see what cancels. You can keep factoring them. That 6 is not what we call a prime number. Prime number, it's too high, isn't it? Yeah, sorry. Prime numbers can only be written as or with factors of 1 and themselves. Two, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and they keep going. After the first prime number, they are all odd. There's actually a neat process where you can have like an entire grid of numbers and show what the prime numbers are by just canceling shit out. It's fucking some ancient dead Greeks guy like Eratosthenes, or I don't know, something C. Maybe I'll look it up and show you guys on Monday. You can always look up a list of prime numbers and go what they are, but you can tell by like the first ones, they don't appear on the multiplication table. That's the kicker right there. There's no product that appears on a multiplication table like you do 1 by 10 and they do the whole thing, and the thing you had to learn in like by 6th grade or some shit like that, or presumably learned by 6th grade, they don't end up in the grid. They might be on, well, after you do times 1, they do. Okay, so where does that help us up here? 6 is not one of these prime numbers, so I could have rewritten the 6 as 2 times 3. And now we can see the 3's cancel here. And if you only have prime numbers left, you can't do anything more to break it down any further. This is 1 over 2 times 2, which is 1 over 4. Some calculators do this for you. My calculator does simplify, and I didn't know it till right now. I just figured out how to do it right now. I don't know, I tried to do this and figure it out earlier, but I tried to do it with adding and subtracting, and I didn't end up with anything that factored in the first place. My fraction button it has this A, B/C. So if I hit 3, that thing right there where it gives me the bracket, which is the fraction, and then 12, my 3 over 12 now shows as 1 over 4. So your calculator may do this. And like if you have a calculator, and bring it on Monday, and we can like, if you don't know how to do it on your own on by Monday, I can help you figure out how to do it. Because like a lot of shit speeds up if you know what you're doing. Sometimes they ask questions like, what is the lowest common denominator? So we need another process just to have some math available that can help us. So like when we're finding these factors, we're really finding things we can divide the big number by. Twelve divided by 3 is 4. 12 divided by 6 is 2. When you do the division thing, these two end up as factors written that way, and the 6 and the 2 end up as factors written that way. And we end up with something that this is called evenly divisible. Which means there was no decimal in the answer. If I did 13 divided by 3, I'm going to have a decimal in the answer, which means it's not evenly divisible. Divisible means you can divide it. Indivisible means you can't. Math is not the only spot we use the word indivisible. Hopefully you all know where the other one we use indivisible, although I don't know that they teach it anymore in schools. Pledge of Allegiance. Indivisible means the nation cannot be broken up, which is bullshit. We can break it up into 50 states, right? So one nation under God, indivisible is my ass. It's divisible. But back to the math at hand. So like, if we're trying to find factors, we're trying to find things that divide evenly in. Preferably the prime numbers. But if you don't do the prime numbers, there's other things we can do. where you'll recognize some other ones. So let's go over some common numbers that divide, like the prime numbers and some other ones that divide in evenly. So like, let's start with 2. It's the first prime number. I wish I could say 1, because 1 times 1 is 1, and it's only 1 times itself. It should be prime, but it's not. We'll start with 2. You can tell if a number is divisible by 2. It's divisible by 2 if it ends in 2, 4, 6, 8, or 0. This means it's an even number. I said odd earlier. I didn't really say what odd numbers were. Odd numbers aren't even numbers. We'll hit odd later on in probability more. Three is the craziest fucking rule. I heard it. I said, that's some bullshit. And it worked. I said, what? And I did it again with another number, and it fucking worked. I said, this is magic. 3. Add up the digits. If that value is divisible by 3, so is the big number. And I use like the hashtag key. That really means number. It's divisible by the bigger number. I know when I first saw that when I was starting to teach this subject fucking 7 or 8 years ago. And when I saw a list of things that was divisible by, I didn't know this rule before then. There's no way that's fucking true. That can't be true. It's like magic. I'm like, what numbers adds up to something I know that's divisible by 3? Or adds up to 3? I know 111 adds up to 3. 1 plus 1 plus 1 is 3. 3 is divisible by 3, which means 111 is divisible by 3. And I'm like, that's bullshit. No way. And then I threw it in the calculator. And sure shit, it was divisible by 3. That's some fucking magic. You may not think so, but I teach this shit and I still think it's magic. I don't know why that works. And if I can't explain why something works, it's magic. Video games, cell phones, computers are magic. I don't know how it works. I've opened them. I looked at them. There's a bunch of metal on top of a green thing. They're really small lines. They all connected. I know electricity goes through it. How the fuck that makes fucking Zelda on my TV screen, I don't know. I have no idea. It's magic. How am I using this calculator to do these fraction shit? I don't know. It's magic. All right. The other common ones you'll check for is 5 and 10. 5 ends in 5 or 0, and 10 ends in 0. Those are the ones that have simple rules. 10's not even a prime number, but I put it up there because it really speeds shit up. If you remember that one, it can really speed up factoring a number, which we'll do in a second. Okay, so you guys ready? why don't we go with a big number? 750. Let's do 750. Let's factor 750. That's a big number. I'll show you the tried and true way that always works, and then I'll show you something that you kind of have to have a little intuition with that maybe you'll develop over time and go for. Always, one way that always works is just keep starting with the small numbers and go up until you can't do it. Check dividing by 2. I could do it by hand if I wanted to, or I just throw it in a calculator. Oh, I have too many 5s there. 750 divided by 2 is 375. So I'm going to show this as 2 and 375. And it helps to circle prime numbers so that you know you don't fuck with them. Because you can't make them go any smaller. Can I divide 375 by 2? If we look at our rules, 375, or to divide by 2, we need it to end in a 2, 4, 6, 8, or 0. And it doesn't. It ends in a 5. So we can't do the 2 anymore. We're done with the 2. Next, we'll check 3. 3 plus 7 plus 5, oops, 5. 7 plus 3 is 10, 10 plus 5 is 15. 15 is divisible by 3, so 375 is divisible by 3. I'm just gonna come over here and divide, shit, fat fingered it. Divide by 3, and I see that 3 and 125 get me it. And 3 is a prime number. I'm going to circle it. I'm going to check 3 again. 1 plus 2 plus 5 is 3 plus 5, which is 8, which is not divisible by 3. So the 3's are done. Next thing, check 5. 5, it needs to end in a 5 or a 0, and it does. So I will divide this value by 5, and I get 25. At some point, hopefully you recognize the number as a multiplication of 2 small numbers, and you don't need to calculate it anymore. But if you do, keep checking it. Check 25 divided by 5 again. It does work. It gives you 5. So 25 is 5 times 5. And we're done. $750 is 2 times 3 times 5 times 5 times 5. Now that I know my calculator does fucking simplifying, I wonder if it does some factoring. I doubt it. There's no way this fucking old ass thing does factoring. That's the fucking soap in the guy's room. The clank, clank, clank. That thing's hella loud for a soap dispenser. All right, so another way to do this 750, which I think is helpful, is recognizing right away that it ends in a 0, which means it's divisible by 10. I know 10 is a number. And if I do 750 divided by 10, look at that, I get 75. Which I didn't need a calculator for. When you divide by 10 and it ends in a 0, you just chop off the last number. The 0 is gone and it tells me what it is. It's 75 right away. That's handy. I like this because I know 10 is 2 times 5. I hope everyone in here knows that. If not, I recommend brushing up on your multiplication table. It can't hurt. You do it enough in real life that it's useful. Now, 75, we already did the factoring for it. We showed this was 3 times 25. But sometimes I think it's helpful to think about other things other than grabbing the calculator. There's a number that you see 75 of a lot in real life. Money, something that has like 75 cents. 75 cents is 3 quarters. Or 3 times 25 cents. 3 times 25. So sometimes if you can relate it to something you know in terms of like other things like money, you could speed that up without having to check it. And you'll notice if I put these in order again, I have a 2, 1 3, and 3 5s. Yes, sir. Cody.
No matter how you factor it, will the answer always be the same?
Yes.
Oh,
If you factor all the way down to the prime numbers. Like, there's no way I would ever look at this and think it, but 2 times 3 is 6, which means 6 goes into this. I would never look at 750 and go, that's divisible by 6. Maybe someone in the class would, and they go, all right, okay, 750 divided by 6 is 125. And they could break it down to 6 and 125 and break those down. That's not me. Like, I've never tried to break up $7.50 into 6 parts. You guys ready for some more? Are we having fun yet? Is this not the best goddamn thing you've done all week? Even better than 4th of July. This is some fantastic shit. Least common denominator. I gotta use the word denominator because that's what's in there. It's got an abbreviation, LCD. I'm pretty sure it's least. It might be lowest, kind of like interchangeable L words for the same meaning, least and lowest. The idea here is the least common denominator is the smallest bottom or denominator we can have where we start with 2 or more unlike fractions and want to write as like fractions. that's not how I said this earlier, but I think this is a good way to introduce like and unlike. This is really, why do this? Why would you ask? Why would we do this hassle? It makes adding and subtracting fractions cake. I'm going to say without a calculator. Easy is different than simple. There are some steps to it. It's not necessarily a simple process, but every step is easy. We won't start off in adding and subtracting fractions first, though. Actually, maybe we will. Let's just start with the whole shindig. I know for sure one of the questions on that initial quiz gives you 3 fractions that have different denominators, and there's addition and subtraction in there, and they say, what is the final answer? You might have something like 7 over 80 plus, do I want to go with plus? Yeah, let's go with plus. Plus 3 over 40 minus 9 over 20. These are called unlike fractions. Because the bottom is different. And we cannot add and subtract unlike fractions without a calculator. I just found out today my calculator does it. And I was excited, that was this morning, but I didn't show that it's simplified. Some people don't have a calculator that does, so you're learning the whole thing. It's useful, it's handy. That might not be those numbers, but every time I did the initial quiz, I took it a few times just to look at what pops out. I think 80, 40, 20 always popped out. I think it was always the denominators. I don't think they had different denominators. I don't think there might be different ones, but I don't recall seeing them. So sometimes it's a little bit easier than others. First thing you should always check is the biggest denominator or the biggest bottom evenly divisible by the others. $80 over 40, which is 80 divided by 40, is 2, and that's evenly divisible. 80 divided by 20, or 80 over 20 is 80 divided by 20 is 4. What this tells me is that for the fraction that started with the 40 on the bottom, whatever my evenly divisible amount was, I can start with the 3 over 40 and multiply the top and bottom by it. If I multiply the top, I have 2 times 3. If I multiply the bottom, I have 2 times 40. I get 6 over 80. And now I have an 80 in common with the other one. I could do the same thing with the 80 and the 20, the fraction that had a 20. I can multiply top and bottom by the 4. 9 times 4 over 20 times 4 is 36 over 80. I'm getting more and more ink on my fingers. So let's slide this up and still leave it there. So if I want to do that addition and subtraction of those fractions, the way you add and subtract fractions, you need to have a common denominator, the same bottom. If the bottom is the same, they are called like fractions. And we can add or subtract them. By rewriting them with that same bottom. I had everything, we wanted to end up with a bottom of 80. The 3 over 80 was the same, or 3 over 40 was the same as 6 over 80. And the 9 over the 20 was the same as 36 over 80. Make sure everyone's caught up before I start doing the next step. Next step is something people commonly fuck up on. Because we do different shit on top and bottom, which confuses some people. Whatever we have here, the denominator becomes the same denominator for all of them. We keep the denominator. Whatever these all are, they go over there. That's the new bottom. Now you can put all the tops with the signs between them up top. 7 plus 6 minus 36. It's kind of important that you do not rush the next step in a calculator, because if I type in a calculator 7 plus 6 minus 36 divided by 80, I'm going to get the wrong value. That is not the right answer. So you always want to do the shit on top, or get the numbers that are added or subtracted together. Get that done first. So what is 7 plus 6 plus, or not plus, minus 36? That is negative 23. This turns into negative 23 over 80. The last step is simplifying. Simplify if you can. which means doing the factoring and canceling stuff out. We cannot do that here. 23 is a prime number. When you have a prime number on the top, just check to see if the bottom is divisible by 23. 80 divided by 23, it's not evenly divisible. I get a decimal. That's bad juju. We don't want it. So it doesn't simplify anymore. That's because the top is prime. The next one we would do will not be prime, and we'll be able to simplify it. I want to give everybody like a 5-minute break. If you need to go to the bathroom or something like that, go to the bathroom. Last class, I didn't do that, and someone got up and like missed part of the lecture. I'm like, shit. Does anyone need to go to the bathroom? Let's take a quick break. Stretch for a second. This was the one I found out this morning that my calculator actually does do it. I gave it a try. There's a fraction button on my calculator. I gave it a try. I'm like, it works. But I didn't know if it reduced because this doesn't reduce. And then I went and looked up one later on that does, I know reduces. Is everybody back? Is there a desk around you with paper on it? That isn't yours? All right, everyone's back. Let's get started. Sooner we're done, sooner you get out of here. Hopefully, we're done before 11:40. All right, so that's where we start with the common denominators that were easy to find a common denominator. Let's take a look at LCD with crappy fractions. I need a new page. Let's go to a new page. When I say crappy fractions, the bottoms have very little in common. Let's go with 3/14 and 7/20 and 9/70. And since we're talking about doing addition and subtraction and why we do this kind of stuff, let's make it minus the 7/20 and the plus 9/70. Someone's in my chat room. What the hell? That'll work, Guadalupe, if you can hear me. You're good. I don't take attendance in class.
Okay, thank you.
I did not know that was a female. I saw your name, just assumed a guy. I've known a lot of Lupes. Cool. All right, so what you can do, and I just found out this morning that someone else has done this, and I'm very, very, very mad, because I came up with this technique in the shower about 7 or 8 years ago, and I think they stole it. I can't prove that though. So the easy method to find the LCD. First off, factor all the bottoms. And then 2, make a table where each column is a unique prime number. I'll say unique number, because sometimes you don't have to go all the way down to the prime numbers to do it. But we're going to do that here. So, like, let's do number 1 here. Number 1. What can I write 14 as? What multiplies to make 14? 2 times 7. And book 2 and 7 are prime numbers. That doesn't get any smaller. What about 20? What can we write that as? You don't have to necessarily start with the prime numbers, just start with 2 numbers you know until you get it down to where you need it. 5 times 4, that's a great option. 5 is a prime number, 4 isn't. So I'm going to break down 4 into 2 times 2. What about 70? It's 10 times 7, right? It's got ends in a 0, so we can do that definitely. You got 7 and 10, and we know the 10 breaks down into 2 and 5. All right, so when I make my table, and generally I skip step 1 and do it straight into the table, but I think it's helpful to see it first this way, just writing out what they are. I'm going to make a little table where my rows are each of the denominators. And I will write the factors for 14, and I will use a column. Just write them down. 20 is 5 times 2 times 2. I already have a column that has a 2 in it, so I'm going to take that 2 and put it right there. And then I still have another 2 and a 5, and I can't put another 2 in the same column, there's no room for it. So I'll make a new column for another 2 and another 5. $70 is 7 times 10. I have the 7 here is already in a column, we'll put it there. The 2 already has a column, we'll put it there. And the 5 already has a column, and we'll put it there. The LCD is you take 1 from each column and multiply them together. 2 times 7 times 2 times 5. 2 times 7 is 14, and 2 times 5 is 10. 14 times 10 is 140. That's my LCD. Which means this is the bottom I'm going to use for all the fractions. You guys ready for some more? Keep going with it. All right, so what I'm gonna do, because guess what? This table has more uses than just that. The gaps here help us. Gaps are useful. So rather than drawing on that same table again and like making it so it's like confusing when I scan this shit later on, I'm gonna redraw that table real quick. And we'll look at the gaps. Okay, I redrew it. And I'm going to show the initial thing that we start with. Let me rewrite that down because this is what we were trying to do. 3 over 14 minus 7 over 20 plus 9 over 70. So what I want to do is I want to rewrite 3 over 14 as something with the denominator of 140. I want to do the same thing with 7 over 20 and 9 over 70. I want to have a denominator of 140 for all of them. Let's make sure we're all on the same page before I start doing it. That last part is the shit I came up with the shower like 8 years ago, and then when I was looking up something between classes, they showed the exact same kind of shit right here, even with arrows pointing down, but they don't do the gap thing. They just assume you can figure out what the gap shit means. I'm going to show the gap shit. That's what they're missing. So, How do I go from 14 to 140? Well, I want this 14 to have 140. It's missing some numbers. It's missing those two numbers. If I had 2 times 7 times 2 times 5, I would have that LCD. So the gap shows me what I need to grab and multiply by. 2 times 5 is 10, which means as I went from 14 to 140, I multiplied by 10. I need to do the same thing on the top, multiply by 10. 3 times 10 is 30. The 20 is missing the 2. Or the 7, sorry, that's a 7 column. It's missing a 7. Multiply by 7, and I get 49 on top. The 70 is missing the 2. There we go. So to go from 70 to 140, I multiplied by 2. I need to do the same thing on top, multiply the 9 by 2, and I get 18. Which means I can rewrite these as 30 over 140 minus 49 over 140 plus 18 over 140. Now, what we did before, we do it again. We make the denominator the same as all the other denominators, is the 140, and we do the operations on top like that. Okay, so now I'm going to do this in a calculator. This is easy to fuck up in a calculator if you get patient and you try to do it all at once. Just do the stuff on top first. That adds up to -1. Oh, that's convenient. The equivalent of doing this on my calculator and leaving it in the initial stuff we started with, my key is the A and then it says B over C. That's my fraction key. I'm going to do that same operation here with that key. I'll clear it all out. And I will do 3 ABC 14 minus 7 ABC 20 plus 9 ABC 70. It does this little bracket in the lower right corner to show the fraction. And when I do it, it also gives me negative 1 over 140. So your calculator may have something similar, and that just sped all that shit up, right up, didn't it? The only thing that kind of actually helps you, it shows you what the lowest common denominator is too. In this case, if it simplifies for you, it doesn't. I don't think it does. We'll check on the next problem. Another way to do this, if you do not have the fraction key, I'll wait for when we're doing decimals for that. Let's take a look at Is everyone ready before I start yanking shit? Didn't even ask. All right. Let's do 9 over 14 minus 1 over 6. This is a problem they have in the book. It's kind of hard to start with a fraction, two fractions, then add and subtracting, and know that it's going to simplify later. You kind of got to work backwards. I tried for a while this morning and said, fuck it. Let's just go into the book and see one they got. So let's do the method we were talking about here. My two denominators are 14 and 6. Fourteen is 2 times 7, and 6 is 2 times 3. I have a column for the 2, I'll make another column for the 3. My LCD is 1 from each column. I don't do 14 times 3 very easily in my head here, but if I do 2 times 3 first, I have 6. 6 times 7 is 42. The LCD is 42. Now I'll start grabbing the holes in the gaps, or the gaps in the chart, and seeing what I need to multiply by. The 14 is missing a 3. So I kind of need to do 3 times 3 here. And rather than just calculating it right away, I'll write 3 times 9. The 6 is missing a 7. So that's kind of like a 7 over a 7. And I've got minus 1 times 7. This is 3 times 9 is 27. Minus 1 times 7 is 7 over 42. And if I clean up the top, 27 minus 7 is 20. 20 over 42. You now want to check to see if it simplifies. And this is where we factored the top and the bottom and we canceled out shit that appeared on both sides. But we've got the table here, and the table speeds this up quite a bit. I already know what the factors are on bottom. This is 20 over 2 times 7 times 3. Now I just need to factor the top. And we know that was 4 times 5, which is 2 times 2 times 5. And the bottom is 2 times 7 times 3. We cancel out the similar things. And I'm left with 2 times 5 is 10, over 7 times 3 is 21. Notice that my denominator and my bottom is no longer the LCD. I've simplified it. If I put this in the calculator, 9 fraction 14 minus 1 fraction 6, it jumps straight to the simplified form. Your calculator may do this too. Now on a problem where it doesn't ask you for the LCD, fuck all this handwriting shit. Just do it in a calculator if your calculator does it. And if you don't know if your calculator does it, bring it on Monday, and we'll do it either before class or after class. We'll figure out how your shit works. And if it doesn't, you have 2 options. You either get a calculator that does, or you use the method by paper. With that in mind, let me give you a practice problem to do yourself. You try. Let's do 3 over 10 minus 6 over 35 plus 4 over 21. After this, we're only doing one more thing, and it only takes a few minutes. So you guys take 5 minutes or so. I was so sad. That lady, that wasn't in this class. There's in the morning class, the girl had the last name Sivarathapan. It's just a long spelling. It's kind of like if you ever read fantasy novels with dragons in them, dragons always have a really long name with like B's and shit like that and X's in them. It reminded me of a dragon name. Oh, and that name is cool. And then she dropped. Now I don't get to say it anymore. That makes me sad. Who needs more time? If you need more time, raise your hand. It's okay if you do. Okay. If you're done and you got 67 over 210, that's what I got. If you didn't, you made a mistake somewhere, and we don't know where it is, but I'm gonna go over it in a second. Just give you time to, are you done now? Did I,
No, I got 210 for logging, but I'm still trying to figure out the time.
okay, keep going. You're almost there then. Pretty sure one of the initial quiz questions asks you to find just the LCD or the least common denominator and not do the fraction thing. So this table is kind of helpful. And while we won't use it in this class, because we don't need it, it's something called the greatest common factor, or GCF, you can also get from doing this table thing. Like that, this was when I was doing a pre-algebra class. I was like, oh, that's what I need, like this. That's not something we need in here, so. All right, let's give it a gander. In the interest of time, I had 10 and 35 and 21. 10 is 2 times 5. 35 is 5 times 7. 21 is 3 times 7. I got a 7. I need another column for a 3. So the LCD is 2 times 5 times 7 times 3. 10 times 21, or 210. Now we'll start grabbing the gaps. The 10 is missing these values, which is a 7 and a 3, and that's 21. Which just means this one needed to be multiplied by 21, which means that one needs to be multiplied by 21. So I've got 21 times 3 right there. 35 is missing the 2 and the 3. 2 times 3 is 6. So this needs a 6 times a 6. So minus 6 times 6. And 21 is missing the 2 and the 5. 2 times 5 is 10. That needs a 10 and a 10, or plus 4 times 10. All right, so if you got to that point, even if you have these as separate fractions, you're doing good so far. 21 times 3 is 63. 6 times 6 is 36. 4 times 10 is 40. And I can do this part in my head if I do, like, I can't do 63 minus 36 easily in my head. I'd have to stop and think about it. But 40 minus 36 for me is pretty easy. 40 minus 36 is 4. And it's a positive 4, which means I got to add it to the 63. I end up with 67 over 210. Is that reducible? I think 67 is prime. I'm just going to check real quick by adding the initial fractions. $67 over 210. Now, let me see if my calculator goes the other way here. I hit the shift key and that, I didn't do it. It doesn't, okay. So if I want to see what that is as a decimal, we're going to do a lot more with decimals on Monday. But recall, this is the same thing as 67 divided by 210. Zero 0.319047619, and it keeps going. This looks to be a decimal that doesn't end and it doesn't repeat. And then what we were classifying earlier as irrational numbers, that was like the criteria of an irrational number. I said it's a candidate for it. This one actually turns into a fraction. But without knowing what that fraction is ahead of time, it's really hard to get to that fraction from where we're at. It really is. There are some fractions that are easy to get back and forth between a decimal, as we'll see on Monday. That's not one of them. Okay, a couple more things. Something else we need to do today is finding average of numbers. It's also called the means or mean of numbers. Step 1, add up all the entries. Step 2, divide the total by the number of entries. We're actually gonna take the full time today. That's a shame. I did a little bit more with your class than I did with the last class because I found a fraction that's simplified. That 9/14 minus 1/6 I didn't do last time. So let's say we've got an example. You've got $16.80. You got $22.10. And you got $80.20. That is still not what I wanted to use, but fuck it, we're gonna go with it. Step one, add these up. What is 16.80 plus 22.10 plus 80.20? Oop. Fucked up. $119.10. Step two, divide the 119.10 by 3. $39.7. That's what the calculator told me, 39.7. Would you ever say $39.7 though? No, you wouldn't. Wow. What will we do here? Hell no, we ain't rounding. We want an exact answer.
$39.70.
We're gonna add the 0. We'll add the 0. That's exactly it. I like your idea. Fuck it, let's just round it. Not always. You don't always want to round it. Okay, now you can do this in the calculator all as one thing, but you gotta do it right. You cannot, don't do 16.8 plus 22.1 plus 80.2. I'm dropping the 0. We'll talk about why you can drop the zeros on Monday, divided by 3. That's gonna get you the wrong answer. I will show you that. 16.8 plus 22.1 plus 80.2 divided by 3. That's getting me 65.63333, which is not $39.70, which means is wrong. And the reason why is the way it's done here is it's only dividing the 80.2 by 3. I recommend doing just adding them up, hitting equal sign, then dividing by the total number of entries. You can't fuck up that way. If you're like, really like, I really want to do it all as one, and you're like one of those achievers, you can do it, but you need to use like a parentheses key. I have a parentheses key right here. I can do parentheses 16.8 plus 22.1 plus 80.2 end parentheses divided by 3 and then equals. If I do that combination, hopefully I didn't fat finger the calculator. It gives me the right answer. Chances are you're gonna forget the parentheses sign. It's easier just to hit equals first and get the total and then divide the total. And that's all the times we've got. If you have a few more minutes, I'll show you something that's useful for that LCD table, going back to that 80, 40, and 20. Does anyone need this up longer? Okay, this is really quick. We could have done the whole factorization on 80. 80 is 2 times 2 times 5 times 2 times 2. I know because, I'm off the screen. Thank you. That is handy. When someone tells me I'm off the screen, that's helpful. Thank you. I know that because I know that 20 is the 2 times 2 times 5. We already know that 20, hopefully you know 20 divides evenly into all those because $20 bills. You can have $20, $40, $60, $80, you're just adding 20s. So this is like 20 times 1. And this is 20 times 2. And this is 20 times 4. If you want to speed up the table and not write out everything multiplied out, leave the 20 alone and just write out the new stuff. If you can identify visually something that divides into all of them, you don't need to break it down. My LCD here is 20 times 2 times 2 is 80. If you had done the full version, you would have had this. Both get you there. That'll save you some time if you see it. It's not necessary though. All right, now you can go. Wait. Get the fuck out. There we go.
Thank you.